Hi friends, welcome to Learning Spark. Today we will be solving SilverZone IOM 2020 paper with explanation and exam tricks. And this is for class 3. If you like this video, please press on the like button, and for more such videos, please press on the subscribe button. Let's get started. Question number 1 is on your screen now. Let's work out the answer together. So the question is basically asking what is the name of the number 569. So if you put it into hundreds, tens and ones place, 5 is going into the hundreds place, 6 is into tens place and 9 is into ones place. So 569, and that's the answer, 569. Pretty easy. Question number 2 is on your screen now. We will work out the answer together now. So the question is, which one of the following has the value of less than 250 minus 125? 250 minus 125 is 125. Okay, so we will go to the answer to check which one is less than 125. Okay, now we use something called method of elimination. Okay, so we will eliminate certain answers, we will not even calculate them. Okay, answer A, for example, 150 plus 25, this is more than 150, so this cannot be less than 125. This cannot be less than 125, so we eliminate it. Second one, 200 minus 25, which is more than 150 again, so we eliminate it again. Third one is 100 minus 25, so this is less than 100, so this can be a value which is less than 125, right? This will be a value actually which is less than 125, and we calculate the value is 75, right? So this is the right answer, and we don't have to calculate the fourth one because we have got the answer. Question number 3 is on your screen now. We will go to the answer now. Let's work out the answer. So the question is, which one of the following abacuses represents the number more than 2000? Okay, if the number is more than 2000, then there has to be at least 2 bits in the thousands place in abacus. But now if we go to the answers, we see that in answer A, there's only 1 bit, so we use the method of elimination here again. Okay, and we directly eliminate this answer A because there's 1 in the thousands place, right? It cannot be more than 2000. Similarly, answer B is also, there's 1 bit in thousands place. Answer D also, there's 1 bit in thousands place. So the only answer that is left, which is having 2 bits in the thousands place and of course more than 2000, is answer C. So this is the right answer. Question number 4 is on your screen now. Let's work out the answer now. It's pretty simple. It is saying that which number is the predecessor of the sum of these numbers. So sum of these numbers, 9 plus 8 plus 7 is 24, and the predecessor of 24 is 23, because predecessor means previous number, right? So previous number of 24 is 23. This is the answer. Question number 5 is on your screen now. Let's work out the answer. So it says which one of the following statement is correct, and then 4 options. And this is basically, you need to know what is multiplication. Multiplication is how many times you are adding the same number, right? So here in option 1, 4 plus 4 plus 4 plus 4. So 4 times you are adding 4. So this is basically 4 into 4, not 4 into 16. So this is a wrong answer. Okay, let's work out the second one. 1, 2, 3, 4, 5. 5 times you are adding 3. Okay, so which is represented by 3 into 5, 3 multiplied by 5. So this is the right answer. right? So we got our answer. We don't have to calculate anymore. Question number 6 is on your screen now. So let's work out this together. So in this question we see that there is a number which is 4A16. There is an unknown digit here, and which is multiplied by 8 to get another number. Okay, and then the question is, what is this unknown digit? Okay, now let's start with this. So if 3 into 5 equals to 15, then 15 by 3 equal to 5, right? If two numbers are multiplied to get another number, then the result can be divided by any one of this number to get the other number, which means that 15 by 5 equal to 3 and 15 by 3 equal to 5. Okay, so by this same logic, if this number 4A16 is multiplied by 8 to get 36128, then 36128 can be divided by 8 to get this number, to get 4A16, right? So let's divide this now. 36128 by 8. Okay, so this result we can get is 4516. Okay, so 4A16 is actually 4516, which means that A's value is 5. All right, so this is the right answer. Question number 7 is on your screen now. Okay, let's work out the answer together now. So the question is, there is a table of letters and there are there's A, B and C in here. So it says that if we add two more B's and remove one A and one C from this table, then what fraction of the total number of letters will be the number of B? Okay, so let's first calculate how many letters are there. Okay, so 1 2 3 4 5 6 7 8 8 letter per row, and there are 3 rows, so 8 into 3 equal to 24 letters are there. And after we remove one A and one C and we add two more B's, how many numbers will be there in the board? So we are basically removing 2 and adding 2. So the 24 is not changing. The total figure, the total number of letters is still 24. Okay. Now we calculate the number of B's. How many B's are there right now? There are 1, 2, 3, 4, 5, 6, 7 B's. 7 B's are there on the table right now. And it is saying that if we add 2 more B's, right? So 7 B's are there and we add 2 more, so it becomes 9. Okay, and then it wants to know what would be the fraction of the B's with respect to the total number of letters. Okay, so B is 29 by together the letters are 24 letters, so 9 by 24 is the fraction. Okay, and 9 by 24 can also be represented by 3 by 8. Okay, because 9 by 24 and 3 by 8 is equivalent fraction. You can divide both denominator and numerator by 3. And if you want more details on this, you can watch my video on equivalent and comparison of fraction. But the answer is 3 by 8. Question number 8 is on your screen now. Okay, let's work this out together. So the question is the fraction represented by the shaded part of which two figures are like fractions. Okay, so let's calculate the fractions represented by the shaded part first. For figure 1, it will be 2 by 4 because the total number of division is 4 and 2 are shaded. Okay, so 2 shaded part by total number of parts, 2 by 4. For second one, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 parts and 2 are shaded. So 2 by 8. Third one, 1, 2, 3. total 3 divisions. So denominator is 3 and numerator is 1. 1 is shaded, so 1 by 3. And fourth one, 1, 2, 3, 4, total 4 parts and 1 is shaded, so 1 by 4. Okay. Now from equivalence of fraction we know that 2 by 8 equals to 1 by 4. Okay, because you have to divide both numerator and denominator by 2 to get 1 by 4. Okay, so this is also 1 by 4, this is 1 by 4. All right, so this is basically equivalent fraction. So the answer is D, figure 2 and figure 4. Question number 9 is on your screen now. Let's work this out together now. So it says that when the fraction represented by the shaded part of figure 2 is subtracted from the fraction of figure 1, the result will be, and then 4 answers. So we have to first calculate what is the fraction of figure 1 and what is the fraction of figure 2, and then we can subtract them. Okay, so figure 1 is 3 by 4. Why? Because there are 4 equal divisions, 1, 2, 3, 4. Out of that 3 are shaded, right? So 3 by 4 is the shaded part is representing, and for figure 2 the shaded part is representing how much? 1, 2, 3, 4, 5, 6, 7, 8. So out of 8 divisions 4 are shaded, right? So it is 4 by 8. Okay, so 4 by 8 you can also, from equivalence of fraction again, you can divide by 2 both numerator and denominator, and you can convert it into 2 by 4. Okay, why? Because you need to subtract, and for fraction, if you want to subtract, you have to have the denominators same. Okay, so if this is 4, this is 3 by 4, this also has to be 4. Okay, so we can convert this into 2 by 4. So simply we have to now subtract 2 by 4 from 3 by 4. Okay, so the answer is 3 by 4 minus 2 by 4, which is 1 by 4, and C is the answer. Question number 10 is on your screen now. Let's work this out together. So the question is, if the total cost of toffees shown below is 36, then the cost of 2 such toffees will be. So let's first calculate how many toffees are there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 toffees are there. So we will use something called unitary method here, unitary method, because to us 9 toffees, total cost of 9 toffees are given. Okay, so we have to first come to 1 toffees. From 9 we come to 1, and from 1 we jump to 2. Okay, that is unitary method. So whatever is given, you come to 1 first, and then you get to the answer. Okay, so total 9 toffees are given. The total cost is 36. So for each of the toffee, what is the total cost? What is the cost? Cost is 36 by 9, which is 4 rupees 4 for each toffee, right? Then it is very easy to calculate 2 toffees. It is 4 into 2 equal to 8, right? So the answer is 8. Question number 11 is on your screen now. Let's work this out together now. So the question is, which one of the following clocks show the time 3 hours before 7:30 p.m.? So it's a simple subtraction. You can subtract 3 hours from 7:30. The subtraction looks like this. So if it is 7 hours and 30 minutes, and then you have to subtract 3 hours, 0 minutes, and 30 minutes, so 30 minus 0 equals to 30, 7 minus 3 equal to 4. So it is 4:30, right? And since it was 7:30 p.m., it will be 4:30 p.m. Okay, and this clock is the only one which represents 4:30. So the answer is D. Okay. Question number 12 is on your screen now. Okay, let's solve this now. So it says that Rahul's birthday falls on the day just before 4th Tuesday of April 2020. Okay, let's see what is the 4th Tuesday of April 2021. So there's only partially the calendar is given, the full calendar is not given, only the first Tuesday is given. The first Tuesday is on 7th. Okay, first Tuesday is on April 7th. So second Tuesday will be 7 days after that, because 7 days is 1 week. Okay, so it will be April 14th. 7 plus 7 equal to 14th. So similarly, if we see fourth Tuesday will be April 7th plus uh, 7 thrice, right? 7 day plus 7 day plus 7 day. So it will be April 28th basically. 7, then second one is 14th, third one is 21st, fourth one is 28th. Okay, so the fourth Tuesday is April 28th, but it is saying the day before the fourth Tuesday. Okay, so if the day before will be April 27th, right? So the answer is April 27th, 2020. Question number 13 is on your screen now. Okay, let's solve this now. So the question basically is the capacity of two jars, it is asked, and it says that one jar equals to 1, 2, 3, 4, 5 bowls. One jar equals to 5 bowls, and then it gives 2 bowls equal to 250 ml. Okay, so let's start this. One jar equals to 5 bowls, so 2 jars equal to 10 bowls, right? So this is equal to 10 bowls, right? Now, how much is the volume of one bowl? We can get it from here. So 2 bowls is equal to 250 ml. So 1 bowl is equal to 250 divided by 2, which is 125 ml, right? And if one bowl equals to 125 ml, then what is the volume of 10 bowls? The volume of 10 bowls is 1250 ml, right? 1250 ml means 1 liter, and 250 to 250 ml, right? And this is the volume of 10 bowls, and 10 bowls equal to 2 jars, and it has asked for the capacity of 2 jars. So the answer is 1 liter and 250 ml, correct? So B is the answer. Question number 14 is on your screen now. Let's solve this together. So it says drum 1 contains some wheat and drum 2 contains some wheat, and how much wheat is there in these two drums. So it is simple addition of these two figures. Okay, let's put it. So these two we will add together. This is 8 plus 5 equals to 13, right? So 1300. So 1300 gram equals to 1 kg and 300 grams. Okay, so 300 grams remains here in the grams place, and 1 kg is carried over to the kgs place, right? So 8 plus 11 equals to 19, and 1 which is carried over, which means total it is 20, right? So 20 kg and 300 grams is the right answer, C. Question number 15 is on your screen now. Okay, let's work this out together. So it says that Susan has a 3 meter 35 centimeter long rope, and Garima has another rope this long. What is the total length? So it is also a simple case of addition. Okay, so let's put it into the addition format. Meter and centimeter, so it's the relationship of 100, right? 100 centimeter equals to 1 meter, and it says 3 meter 35 and 4 meter 65 centimeters. So 35 plus 65 equals to 100. Okay, and for 100 it goes into it's carried forward, carried over to meters place, right? So 1 meter plus 3 plus 4 is 7, and 1 is carried over, so total 8. So 8 meter 0 centimeter, which is 8 meter. Okay, so the answer is A. Question number 16 is on your screen. Let's work this out now. So the question is, which one of the following is not a ray in this figure? Okay, so first of all we need to know what is a ray. Array is something where one side is fixed and one side is expandable, right? And expandable is shown by an arrow sign. So this one, for example, is a ray. DE is a ray. One side is fixed, so it's not expandable, so no arrow. And the other side is expandable, so there is an arrow sign. Okay. So which one of this is not a ray? CP, for example, is a ray. CP, so one side is no arrow, the other side is arrow, so it's a ray. AB is a ray because A is fixed and B is expandable. DE is also a ray because D is fixed and E is expandable. CA, C and A, so both are fixed. There is no expandable, there is no arrow. So this one is not a ray. It's actually a line segment. Okay. So this is the answer. Question number 17 is on your screen. Okay, let's go to the answer now. So it says, which one of the following triangles is neither an isosceles triangle nor an equilateral triangle, right? So first we need to know what is an isosceles triangle and what is an equilateral triangle. So isosceles triangle is a triangle where any two sides are equal. An equilateral triangle is all sides are equal. Okay. So we have to find out a triangle where there are no two sides which are equal, because if there are two sides are equal, it becomes an isosceles triangle, and not to say all sides are equal is also not acceptable. Okay. So this, for this one, for A, all sides are equal. This is an equilateral triangle. So this is not the answer. Second one, this one, isosceles triangle. These two are equal, right? Both are 5.5 centimeter. Okay. So both are equal. It's a isosceles triangle, not an answer. So C is this one is different, but these two are equal. These two are equal, so this is also isosceles triangle. Only the fourth one, where this is 5 centimeter, this is 5.5, this is 6.5. All three are different, so neither this is isosceles nor this is equilateral. So D is our answer. Question number 18 is on your screen now. All right, we will solve this together now. So the question, let's go to the question first. How many ice creams were sold in the first 4 months of the year? Okay. So first 4 months, this is January, February, March, April. So let's first count how many ice cream icons are there in each of these months, right? Before that, you need to know that, each of this ice cream icon actually represents 10 ice creams. But we will not multiply them at first. Okay, we will first calculate, add everything together, and then we will multiply. So this is a trick you should remember. Do not multiply first, do not multiply with everything. First count the icons together and multiply at the end. Okay, so let's do this. First count, there are three icons. This is 2, this is 6, and this is 4. So together 3 plus 2 plus 6 plus 4 equal to 15. Okay, so 15 ice cream icons together, and then each icon represents 10 ice creams. So together how many ice creams? 15 into 10, 150 ice creams, right? And which is our answer? B. Question number 19 is on your screen. Okay, let's do this now together. Pretty straightforward. How many line segments? Let's count. So if we start from here, right, or from this point, then 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 line segments are there to form this figure. So the answer is 9. Question number 20 is on your screen now. Okay, let's solve this now. So the question is that who completed the race before Amar but after Ali? So a couple of people and their graphs are given here. So we have to find out somebody who has who has completed before Amar and after Ali, means we in the mid of Amar and Ali's graph, right? So let's see what is this is Ali's graph, right? Ali's graph ends here. So this is Ali. Ali has taken 32 seconds, and this is Amar, taken 64 seconds. So somebody who is scoring in between Amar and Ali. We can see only one graph which is ended in between Ali and Amar, which is 56, belongs to Mohit. This one, right? So this is our answer. The answer is C, Mohit. Question number 21 is on the screen. Let us go to the answer now. So the trick here in this question is that if the numbers are grouped together, then you try to discover a pattern among the numbers. Okay. So here, for example, 1, 3, 2. Let's make a pattern to find 5. Okay. The 5 is placed differently, and 1, 3, 2, they are placed, in a similar way. So 1, 3, 2, this should form a pattern to result 5 or get 5. 4 2 5 should result in a pattern to get 13. Okay, so what is the pattern? Let's see. Here the pattern is that we just observe the number to find the pattern. So this 1 into 3 plus 2 equal to 5. Okay, let's see whether the pattern matches here also. So 4 into 2 equals to 8. 8 plus 5 equals to 13. Okay, so if we follow this pattern, this number into this number plus this number becomes this number. Okay, so let's see, continue the same pattern here. So 7 into 2 equals to 14. 14 plus 1 equals to 15. Okay, so let's apply the same pattern in the fourth one. So 5 into 4 equals to 20. So 20 plus 3 equals to, it will be 23, right? So the answer will be 23. Question number 22 is on the screen. Let us solve this now. So it says, keeping in mind the type of numbers, find the odd one out. Okay, so 4 options. Let's calculate the numbers first. So 3 plus 2 5, 7 plus 2 9, 11 plus 2 13, 17 plus 2 19. Okay, now type of numbers, what does it mean? It can be odd versus even, right? So let's see odd and even. So this is odd number, this is odd number, this is odd number, this is also odd number. Everything is odd. So nothing is different here, right? So the type of numbers odd versus even doesn't work. Let's try prime versus composite. Okay, so let's see, 5 is a prime number. 9 is a composite number, by the way, because 9 equals to 3 into 3, right? So there are other combinations possible other than 1 and 9, multiplying 1 by 9. There are other combinations possible, so it is not a prime number. 13 is a prime number and 19 is a prime number. Okay, so 9 is the only composite number here, so this is the odd one out. Okay, the answer is B. Question number 23 is on the screen. Let's solve this now. So how many triangles are there in this figure, right? In this kind of sums, you can use a trick. First, divide into smallest parts and name them, and then you try to club them and form the figures that is wanted. So here, for example, we name this. There are the smallest parts are, this one is A. Let's name this one B, this is C, and this is D. Then let's take one by one. Okay, let's take one figure at a time and let's see how many triangles are there first. So take one part to check for triangles. B, C, D are triangles, right? A is not a triangle. B, C, D are triangles. Okay, so three triangles. Now you take two figures, two parts to check for triangles. Okay, so two parts, which are the two parts which can form a triangle? A plus B can form a triangle. So this one, A plus B, can form a triangle. C plus D can also form a triangle. Okay, none of the two other figures can form a triangle. B and C cannot form a triangle. A and C, or A and D, or any other possible combination cannot form triangles. Only these are the two combinations that can form triangles. Now let's see 3, 4 or 5 parts together to check for triangles, and you will see there is no triangle at all. Okay, so total, how many triangles are there? 1, 2, 3, 4, 5 triangles. So 5 is the answer. Question number 24 is on your screen. Let's solve this now. This is a question about pattern. So which one of the figure will complete this figure, the given figure, right? So you can see there are some of the characteristic of the given figures. So there are three circles, none of these are filled. Okay, three circles, and then there is some corner patterns are there. In each of the corner there are some corner patterns. So we need to find a pattern which has such kind of a circle, which is not filled circle, and also which has pattern. Okay, so let's see. In A you don't have the corner pattern, right? So that is not the correct answer. Okay, and B, for B you have the corner pattern. Here the corner pattern is there which can complete this, but then the circle is filled by black color. Okay, which is not matching with the other circles. So this is not the answer. Answer C is there is no corner, again there is no corner pattern. Okay, so answer D, there is corner pattern which can match this corner pattern, and there is a circle which is not filled, right? So this one is the correct answer. Question number 25 is on your screen. Let's solve this now. So which one of the following fruit is in southwest of point O? Okay, and east, the east direction is given. Let's draw the other directions. So this is east, this is west, north and south, right? Now we want to find out what is southwest. Southwest is in midst of south and west. Okay, so this is south, this is west, so this is southwest. Grapes is the fruit which is located in southwest of point O, right? So the answer is grapes. Answer C. Question number 26 is on your screen. Let's solve this together now. This is a little complicated one. So it says that this figure is made up of 4 identical squares. Okay, so all of these are squares and all of these are identical. Very important point. Find the perimeter of the whole figure. Okay, so we have to find the perimeter. So we start with we first have to measure what is the measure of each of the sides of this square. Okay, and we can get it from here. See, this two sides together, it is 22 centimeter, that's given. Okay, so each of the sides will be 11 centimeter. This is 11, this is 11, and if one of the side is 11, then all the sides of all the squares are 11, right? So all of these are 11. Okay, so we have got most of the sides. Now we can calculate the perimeter. The only two sides that we have to find out is this one, because this one is not 11, this is partially occupied, and this one. Okay, this one is also not 11, right? So these two sides we have to find out now. Okay, so for finding out this sides first, for finding out this side first, okay, let's see first what is this one. Okay, this particular area, this particular length is 3, because this is 8, right? And the whole uh, side of this square, this whole side is 11, correct? That we know. And this is 8. So 8 plus 3 equal to 11. So this is 3. This one is 3. Okay. Now consider this particular side. This particular side is also 11, correct? And this is 3. So remaining is 8. This one is 8. Okay. So we have got this particular side. This particular length is 8. We have got this. Now the other one we have to get. Similarly, we have to get the other one. Okay. So this one, this first we need to find out this one, right? This whole figure is, whole length of this side is 11, and this one is 6. It's given that this one is 6. So rest of the length is 5, because 6 plus 5 equal to 11, correct? Now you consider this particular side. This particular side is also 11. Okay, and since this is 5, the rest of the length is 6. So this one is 6, right? So now we have got this one also. Okay, so we have got all the length which is needed for calculating the perimeter. Now let's start calculating the perimeter. Okay, we need to start from a particular point, which is this point, and we will go anti-clockwise. Okay, so first we get 11, then another 11. Okay, so you just calculate it here, 1 11, second 11. Okay, so this 11, this 11, then this is 8. Okay, so third one is 8, fourth one is 11, fifth one is 11, sixth one is 11. Okay, so 11 11 11, seventh one is 6. Okay, 6, then eighth one is 11, ninth one is 11, 10th one is 11. Okay, so 8 9 10th, then again there is a 6 here, this is 6, and then this one is again 11, right? And then this one is 8. Okay, which is this, and then the final one is 11. Okay, so it comes down to this point again. Okay, so how many 11s are there? So we have to add all of this to find the perimeter. We have to add all of this. So how many 11s are there? 1 2 3 4 5 6 7 8 9 10. So 10 11s are there, 2 8s are there, and 2 6s are there. Okay, so let's add this now. 10 11s means 110, 2 8s means 16, 2 6 means 12. Okay, and then add this together, 110 plus 16 plus 12, which is 138, right? This is the whole perimeter. So 138 centimeter is the perimeter. The answer is D. Question number 27 is on your screen. Let's solve this together now. So the question is that there is a figure given, 5 squares are shaded. It says that how many more such squares should be shaded so that the fraction represented by the unshaded parts of the whole figure is 2 by 3. Okay, so we will start by counting the number of squares here. So total square is 6 into 6, 1 2 3 4 5 6. There are 6 boxes or 6 squares in each of the row, and there are 1 2 3 4 5 6 rows. Okay, so 6 into 6, total 36 squares are there. And how many are shaded? 1 2 3 4 5. Out of that, 5 are shaded. Okay, now it says that we have to shade in such a way that the unshaded part of the whole figure will be 2 by 3. Okay, so how many has to be unshaded finally? So total 36 boxes are there, or squares are there. So 36 into 2 by 3, right? Which means that 33 by 3, which is 12, into 2, which is 24. Okay, this is basically division, and this you have to multiply, right? So 24. So 24 figures has to be unshaded to make it a fraction of 2 by 3. Okay, so finally 24 figures have to be unshaded, which means how many figure has to be shaded at the final figure? 36 minus 24, which means 12 has to be shaded. 12 squares have to be shaded finally to make it 2 by 3 unshaded, right? So right now, how many are shaded? Right now, only 5 are shaded. And how many has to be shaded in the final figure? 12 has to be shaded. So how many more has to be shaded? 12 minus 5, which is 7. We have 7 in the answer, which is answer B. This is our answer. Question number 28 is on the screen. Let's solve this now. So there are a couple of statements given. 4 statements are given, and there are some combinations are given. We have to see which combination is the right combination. Okay. Now the trick to solve this problem is that we can see the answer pattern. Okay, and we want to solve the question for which all options are different, or most of the options are different. Okay. For example, here for 3, okay, for question 3, if we solve question 3, A, B, C, D, so all the options are different, you can see, right? So if we see that B is correct answer, we can right away get that this is the correct answer. If we find out that solving 3, A is the right combination, then we can right away find out that this is the one. Okay. Whereas if we solve question number 1, then there are 2 C's, there's 1 C and 3 B. So if B is correct for question number 1, we do not get the answer right away. Okay, there are 3 combinations that is possible. So that is why we will solve 3 only. Here we will solve 3 only. Okay, we can directly have the answer from question 3, only solving the question 3. So the question 3 says the difference of numbers of toffees taken by Mukul's sister and Mukul's friend. Okay. So Mukul's sister, how many toffees Mukul's sister has taken, we will find out. And how many toffees Mukul's friend has taken, we will find out. Then we will subtract them. Okay. So let's go to the sum now. So Mukul has 80 toffees. He gave 2/5 of this to his sister. So his sister will have 80 into 2 by 5, right? 2 by 5 means what? 80 by 5, which means 16, and 16 into 2 equals to 32. So total 32 toffees his sister will have. Okay. Now next is how much his friend will have, right? His friend will have 3/8 of the remainder of the toffees. Okay. So remainder, let's find out the remainder. The remainder means how many are remaining. So 80 toffees were there, 32 toffees are given to the sister. So 48 toffees are remaining. Okay. So 3/8 of the remainder his friend has got. So 3/8 of 48, which is the remainder. So now let's do this. 48 by 8 means 6, and 3 into 6 equal to 18. So Mukul's friend has got 18, sister has got 32, friend has got 18. Now we have to find the difference, which is 32 minus 18, which is 14. Okay, so 14 is given here. So D, right? D will go with 3. Okay, so 3D. 3D is correct option here only. Okay, in this option 3 is marked with D. So C is the right answer for us. Question number 29 is on the screen. Let's solve this now. So it says when 196 is divided by an unknown divisor, then the quotient is 39 and the remainder is 1. So we have to find the divisor. Okay. So first of all, see, the remainder is 1. Okay, so if we remove the remainder, if we subtract the remainder from this number, then it becomes 195. 196 minus 1, 195, and this 195 will be fully divisible by the unknown divisor, right? It will be fully divisible and the result will be 39. Okay, so let's work with 195 instead of 196. Let's work with 195, which will be fully divisible. Okay, now let's consider this. See, if 15 by 3 equals to 5, then 15 by 5 equals to 3, right? So you can interchange the divisor and the quotient. Okay, so if you are dividing a dividend by the divisor and get the quotient, then you can also divide it by the quotient to get the divisor. Okay, so that can you can interchange those two. In this case also we will interchange. How? So if 195, so 196 minus 1, we have already done that. So 195 by the divisor, unknown divisor, equal to 39. Then we can say that 195 by 39 equal to the unknown divisor, right? So we have to simply then divide 195 by 39 to get the divisor. Okay, so 195 by 39, but you don't know the table of 39. Nobody knows the table of 39. So what do? So here you have to bring 5 in ones place. You have to bring 5, right? So you can try 5. Okay, you can try 39 into 5 and see whether 195 is coming. Okay, and in this case 5 is the answer. Basically you can try that, but 5 will be the answer. Okay, so 39 into 5 equals to 195. Okay, so 5 is the unknown divisor here. Okay, so answer is A. Question number 30 is on the screen. Let's work this out together now. So it says that if A is the greatest number among all the numbers written in this blackboard shown below, then the difference of the greatest number and the smallest number cannot be, and then there are 4 options. Okay, so first you need to calculate the difference between whatever greatest and smallest number is present now. Okay, so what is the greatest largest and smallest number right now? Here on the board 62 is the largest number. Okay, and the smallest number is 13. Okay, so what is the difference between 62 and 13? It is 49, right? So 49. Now it is saying that A is the largest number, right? We don't know what is the value of A, but we know that the difference between A and 13 will be more than 49. Otherwise, how can A be the greatest number, right? If A is the greatest number, then the difference between A and the smallest number, which is 13, has to be more than 49. Okay, so it is saying the difference of the greatest number and the smallest number cannot be, so it has to be more than 49, right? So this is more than 49. 54 is more than 49, so this is okay. It can be for 54, it can be 51, it can be 75. The only thing which is less than 49 is 48. Okay, so the difference cannot be 48. This is the answer. Okay, hi friends. If you like this video, please press on the like button and please do not forget to share it with your friends. For more such videos, press on the subscribe button of the channel and then press on the bell icon to get notified. Thank you.